All right, hello class, and this is the video for slope-intercept form. That is the lesson for the day, okay? And we do have some vocabulary with this lesson, and the vocabulary is just going to be y-intercept, okay? And the y-intercept is the point where the line crosses the y-axis. So here's what I mean by that. If I have a graph, so I'm just going to draw it really quick over here. Here's a coordinate plane. And then let's say here is my line on that coordinate plane. So I graph this a linear function. There's the graph of the line on my coordinate plane. The y-intercept is the point where the line crosses the y-axis. So it would be, here's my y-axis right here. This is my y-intercept, wherever this line crosses this axis. Okay, and we'll see a couple more examples of that when we look at actual graphs in a little bit. But that is the y-intercept. Okay, and what we're going to talk about today is slope-intercept form. Now, when we've talked about linear equations or linear functions in the past, oh, there's the bell. Let's wait. Okay, sorry about that. So when we've talked about linear functions in the past, we've talked about this form y equals mx plus b. Well, the reason why we talked about this form y equals mx plus b is because all linear functions are going to be in this type of format. The reason why they're in this format is each piece of the slope-intercept form of the y equals mx plus b means something, okay? So we're going to talk about what every single piece means, and we're actually going to find out an easier way to graph these equations rather than just making a table, okay? So if I have the slope-intercept form of y equals mx plus b, my m is equal to my slope every single time. And then the b is equal to the y-intercept, or the point where the line crosses the y-axis. And that's going to work every single time. So whatever number is being multiplied by x in my equation is going to be the slope of that line, or we also know slope as rate of change. Okay. And then whatever the number that's not being multiplied by x, but that's just kind of being added or subtracted on the end, is going to be my y-intercept. It's going to be the point where the line crosses the y-axis. This works for all linear functions. This will never not work if the function is linear. Okay. Let's go ahead and look at some examples just to clarify any questions that we may have. Okay, so here's my slope-intercept form. I know that this is my slope, and I know my b is my y-intercept. Okay, so I need to identify the slope and the y-intercept of this equation right here, y equals negative 3x minus 2. Okay, so y equals negative 3x minus 2. My slope is going to be the numbers, the m right here. So I want to see, look at this equation, look at my format y equals mx plus b, and figure out which number is my m. Okay, well my m is a number that's being multiplied by x, is negative 3. So my slope of this line is going to be negative 3. Okay? And then my y-intercept is the number that's being added or subtracted on the end. And I need to make sure I bring the sign with it. So there's my y-intercept. It is negative 2. And I'm done. So my slope is negative 3. My y-intercept is negative 2. That's all we needed to do at this point right now. Let's do one more. Okay, one more, and then we're going to look at some different types of problems. So I have slope-intercept form, y equals mx plus b again. I want to identify the slope and the y-intercept of this equation right here. But if we notice, this equation's in a little bit different order. Now I have y equals 3 minus 4x. And I want to identify my slope, and I want to identify my y-intercept. Okay, well, remember, the slope is always a number that's being multiplied by x. Okay, this 3, even though this 3 is the first number that we see, so normally our slope comes right here, it's not being multiplied by x. This negative 4 right here is being multiplied by x. I can actually rewrite this equation. What I could do is I can move these pieces around right here, put them in boxes, and I can reorder this by taking the sign with the 4x. I can bring the subtraction sign so it becomes a negative 4x. And I can switch these around so that now it becomes y equals negative 4x plus 3. This equation right here is the same thing as this equation right here. But this equation is a little bit easier for me to read because it's in this format right here. And it makes it a little bit easier for me to see that the number being multiplied by x is my slope, which is -4. So slope equals -4. My y-intercept is the number that's being added on the end. So my y-intercept is +3. And I'm done. And the cool thing is that what we can do with this information, the reason why we're finding the slope and the y-intercept is because it's going to help us graph. Okay, it leads us to graphing these functions a lot easier than making a table and then graphing the points. Okay, so what I want to do though is I want to look at a graph and see if we can identify the slope and the y-intercept just from looking at this graph. So first thing I want to do is I want to know what let's just look what the y-intercept is. Okay, and that, again, the y-intercept is the point where the line crosses the y-axis. So here's my y-axis, here's my x-axis. So I want to see, where does this line cross the y-axis? Well, this line crosses the y-axis right here. What is this point is what I want to know. What is the point? What is my y-intercept? Well, let's see. X is going to be 0. But the point goes up 1, 2, 3, 4. So my y-intercept is 0, 4. Okay. Now what I want to do, so I already got half the problem done. I know my y-intercept is going to be 4. Now what I want to do is I need to figure out what my slope is. So I need to figure out another point on this line and then count my rise over my run. Okay. And if we look here, let's see, where is there another point on this graph? Where is there another point? It looks like here's a point right here. So here's another point on my graph. So what I'm going to do is I'm going to count what's the change in y, what's the rise, and then what's the run between these 2 points. So if I'm going from here to here, I need to figure out what's the change going up and down, what's the change going left and right. So rise over run. Okay, that is how I find my slope. So my rise is going to go down 1, 2, 3, 4, 5. So there's my rise. And then my runs, I went down 1, 2, 3, 4, 5. My run is 1, 2, 3. So my rise is 5, my run is 3. The slope of this line is 5/3. Except, I also need to look, I went down 5, and down 5, I'm sorry, I should have caught this earlier, is actually negative. Because I'm going down and not up, and this is a negative slope. If I read it left to right, I'm going down the hill, negative slope. And I'm going down, and then over to the right. That's -5/3. So my slope is -5/3. Now, if I wanted to write the equation of this line, I know my equation has to be in the format y equals mx plus b. I know what my m is. My m is my slope. So that's going to be -5/3. I know that my b is my y-intercept, which is +4. Now I'm just going to add my x, add my y, and the equal sign. I'm done. Here's my equation of the line. I just plug in my slope and my y-intercept into that equation. Let's look at another one just to be safe. Okay, find the slope and the y-intercept of the line. Write an equation of it. So first thing I want to do is figure out what is my y-intercept. Okay, let's put it over here this time. Where does this line cross the y-axis? Where does this graph cross the y-axis? Here's my y-axis. So I'm looking, where does it cross the y-axis? And it's right here. This point is -1, 2, 3, 4. So my y-intercept is -4. Now I need to find another point on this graph. And if I look, it looks like there's a point right here. And now I can calculate my slope, or my rate of change, my rise over my run, between this point and this point. So my rise over my rise is 1, 2, 3. And then my run is 1, 2, 3, 4. So my slope for this line is 3/4. So I have my slope, I have my y-intercept, I want to write the equation of the line in y equals mx plus b. So my slope is 3/4. Let's add the x. My y-intercept is -4. So there's my y-intercept because that's the b. And that's all still going to be equal to y. There's the equation of my line. I am all done. Okay. Oops, let's go over here. So what if I wanted to write the equation of the line with a slope of 1/2 and a y-intercept of -1, and I had to graph it? Okay, well now, so I have the equation of a line with a slope of 1/2 and the y-intercept of -1. So I want to write the equation first. Again, no tricks here. It's still going to be y equals mx plus b. Here's my slope, which is 1/2. Here's my y-intercept, which is -1. I'm all done. Y equals 1/2 x minus 1. There's my equation. Now I'm going to figure out, how do I actually graph this equation? I'm going to start at my y-intercept, okay, because I know where that is on the graph. That's where I'm going to start. Start at my y-intercept. So if I start at my y-intercept, I know that that's where the point where the line crosses the y-axis. Well, that's going to be at -1. So it's going to be, here's my y-axis, here's -1. There's my y-intercept. There's one point of this graph right here. This is where the graph crosses the y-axis. Now from here, I can use my rate of change, my slope, to graph another point on the line. Remember, slope is rise over run. So if my rise over my run equals 1/2, that means I'm going to rise 1 and go over 1, 2. 1/2. Rise 1, 1, 2. Up 1, over 2. Up 1, over 2. And then now, if you notice, all these points make a straight line. And it should go the other direction as well. And there's the line. That is the line of the graph y equals 1/2 x minus 1. Okay, so start with your y-intercept and then graph the slope by going up 1 over 2. Okay. Finally, one more problem I want to show you. A line passes through the point 1, 2 and passes through the y-axis at 5. What is the equation of the line? Okay. What we need to do for this problem is, there's a couple ways to solve it, but what the easiest way to do this is go ahead and graph it. Okay. So if I know if it crosses the y-axis at 5, 1, 2, 3, 4, 5, there's my y-intercept. My y-intercept is positive 5. So I know it's y equals mx plus b. Okay. So right now I know my b is positive 5. I need to figure out what my slope is here, and then I'm all done. Well, I know it passes, so here's one of my points. The other point is 1, 2. Well, if I go 1, 2, that's another point right here. I can calculate my slope by counting my rise over my run. And then that'll tell me what my slope is. So from here to here, I'm going to go down 1, 2, 3 over 1. So that means my rise over my run is -3 over 1. So my slope is just -3. And I'm all done. Okay, whoops, I crossed it off there. So it's -3x plus 5. That would be the equation of this line. Okay, so just a quick recap, and this video is just about over. Okay, the biggest thing, you guys, is slope-intercept form, y equals mx plus b. M is my slope, b is my y-intercept. Okay, oh, my intercept didn't even, there we go. B is my y-intercept. The y-intercept is where the line crosses the y-axis. Okay, here's my y-axis, so my y-intercept is here. My slope is my rise over my run, and I can count that on the graph just by counting the rise, how much it goes up and down, and then the run, how much it goes left and right. Once I do that, I replace my slope with m and y equals mx plus b, and I replace my y-intercept with b, and that gives me the equation of a line. Okay, I hope this video helped. Please leave comments and questions in the YouTube question box on the bottom, and thank you very much, you guys. Good luck.